So in this module, we've taken a look at the underlying collection of classes that are used to process requests in ASP.NET and how those classes are mapped onto by various versions of IIS. And more importantly, we focused on the 3 extensibility points of the pipeline. So how can you add your own custom functionality into the request processing architecture of ASP.NET? And we did this in 3 ways. We built custom applications. So you do that by writing a global ASAX file and adding event handlers. We wrote a custom handler, and that's done by implementing the HTTP handler interface and setting up a configuration file mapping to associate a particular path and extension with your endpoint class. We also looked at how to configure IIS to properly dispatch requests onto custom handlers that you might have built. And then finally, we looked at modules, custom modules. How do you build a class that can intercept or add handlers for all of the application level events that we looked at, but not be housed in a global ASX file, instead be built in a separate class definition, which you could deploy as an independent assembly and conceivably apply across all applications on a single machine. So hopefully that gives you some ideas of how you can tap into the pipeline and also how requests are processed in general in ASP.NET. We're going to start here by looking at what happens to a request when it comes into IIS and how is that ultimately dispatched onto ASP.NET. And then we'll begin diving into the pipeline itself. Now, the way this works is going to differ slightly between versions of IIS, so I want to make that clear. And in fact, before I even go into these bullet points here, what I'd like to do is go out to a sample page, ASP.NET page hosted in IIS, and just sort of go through the motions of accessing it so we have a framework of what's going to be happening in our mind. So what I've done here is I've taken a sample from a preceding module, the control-based programming discussion, and this is just a page that's got a bunch of stuff in it. So it's a ASP.NET page with a bulleted list, and it's got a run at server H3 element, and it's got a label and a calendar and some other stuff. So it's typical ASP.NET page with a bunch of stuff in it. And what I'm going to do is just access this page via the browser and host it in IIS. And to do that, I've simply placed it in the inetpub www root directory, which is the default directory for the default website directory for your machine. And then I just want you to sort of think about what happens when I make that request. Okay, so initially we're not going to have the web server running at all, the process running. In fact, let's go kill this guy, which is the worker process that IIS is hosted in. Okay, so there's nothing running right now. So what we're going to have to do when we access the site is IIS is going to have to kick off the process, and then it's going to have to go locate the file. This is the endpoint right here, and somehow it's going to have to take these 2 files and turn them into a couple of class definitions inside of the worker process, and then invoke a method on a resulting instance of the class. So let's go ahead and try this. That was hello CB, so I'm just going to go to HTTP localhost hello CB.aspx. Okay, and that's going to bring up the process. Notice W3WP is now running here. I'm running an IS7, so that's the worker process that's going to be hosting all of this. And the ASP.NET page was instantiated, and when we looked at this previously, the assembly that contains the class definition was dropped onto the disk at this location. So all of that took place in the context of this request being made. And that's really what I want to focus on, is how does that whole process happen? What are the various pieces involved? Who's talking to whom? And how could we potentially influence that process along the way? So let's start by talking about IS 5 and 6 first, because those are slightly different. Well, they're all a little bit different, but IS 7 is notably different. So in IS 5 or 6, IIS is going to receive the initial request for the page. That's the guy that's listening on port 80 and 443, etc. And in IS 5 and 6, the way the request is identified as an ASP.NET request and dispatched onto ASP.NET is the ASP.NET ISAPI DLL. This is an unmanaged DLL. Is registered for ASP.NET extensions. So ASPX, HX, AXD, ASMX, etc. So all of the ASP.NET extensions are associated with that ISAPI DLL. And then in IS5, what's going to happen is the ISAPI extension is going to pass the request on to the worker process, which in that case is ASP.NET WP. Or in IS6, you're already going to be inside of the worker process because IIS is going to be running in the context of the worker process as well, not in a separate one. And it will dispatch the request directly to ASP.NET. But again, it will have had this ISAPI DLL registered for ASP.NET extensions. And then ASP.NET is going to take over. And that's when the whole class is going to be parsed and turned into the file is going to be parsed and turned into a class definition and invoked to process the request. And then when it's done, it's going to send the request back to IIS and ultimately return to the client. So in ASP.NET, in IS7, things get a little bit different because there's no longer any need to have this ISAPI extension registered because ASP.NET is a first-class entity in IIS. That is, its handlers and modules are recognized as valid objects that can be dispatched to directly by IIS. So you don't have to go through that unmanaged ISAPI interface that we've had to go through prior to IS7. So it actually things actually get a bit simpler because IIS simply receives a request. It has an association for ASPX with a specific managed class, which in this case is going to be the page handler factory, and it will go ahead and take care of finding or creating the class needed and dispatching the request. So next we'll take a look in more detail at each of these and how the request goes through, and more specifically how ASP.NET actually compiles and generates the code for these endpoints. Let's now take a more detailed look at how requests are dispatched onto ASP.NET endpoints in each of the respective versions of IIS you might encounter. This is important to understand as you deploy your ASP.NET sites because there are things you might do slightly differently, implementing your handlers or deploying your modules, depending on which version of IIS you end up deploying to. Now, the good news is everything that happens inside of the worker process with respect to ASP.NET right in here, that's going to be the same regardless of which version of IIS you end up deploying to. And that's where we're going to be spending most of our discussion in this module. But again, I just want to start off by pointing out some of the differences between the various flavors of IIS so that you don't get surprised by things happening differently. So in IS5, request comes in. Here's our GET request. The ASPX endpoint is going to have an entry in IIS with a script map association, creating mapping from ASPX onto the ASP.NET ISAPI DLL. Okay, that's the ISAPI extension that's registered for ASP.NET endpoints. And the request is going to be handled by IIS's worker process. In IS5, that's inetinfo.exe. And it's going to be a separate process from the ASP.NET worker process, which is by default ASP.NET_WP.exe. So they actually had to set up some inter-process communication here in the form of a named pipe connection, so that when the request is processed by the ISAPI handler, it will dispatch it via the named pipe connection over to the worker process, at which point ASP.NET takes over and begins locating the endpoint and processing the request. And then at the end, ASP.NET needs to funnel that response back over to IIS so it can serve up the response back to the client. Now, a couple things of interest here that happen inside of the worker process. And again, this is going to be the same regardless of which version of IIS you're working with. But once the request is dispatched onto ASP.NET, it needs to identify the endpoint and construct an instance of the class that is capable of handling that request. And the way this happens by default for ASP.NET pages is there's a handler factory. In fact, it's called the page handler factory. And this guy implements the HTTP handler factory interface. And its job is going to be to identify whether there already exists a compiled version of that class in memory, has the assembly been loaded? Is that type already in the worker process? And if it's not, we need to go construct it. So the first time you get a request for a new endpoint, a new page, it's actually going to go out to the disk and locate that file, the foo.aspx in this case, and that's then going to be parsed and compiled into an assembly, and we saw this in our earlier discussions. And the assembly is then going to be dropped onto disk, and then the assembly is going to be loaded into memory, and the page associated with that file, foo_aspx in this case, is going to be instantiated, and it will have its process request invoked on the HTTP handler interface. So all those pieces will have to happen the first time, but subsequent times the assembly will already be loaded in memory, the type will already be available, so all that will have to happen is the handler factory will simply call new on an instance of foo_aspx in this case, and dispatch the request onto a fresh instance of that class. Okay, so that's the procedure in IS5. When you switch to IS6, a couple things change here. Again, most of the internals for ASP.NET are going to stay the same, so you don't have to worry about doing anything different there. But inside of or outside, when the request comes in, it's no longer handled by a separate worker process. So keep in mind that IIS is hosted in the same worker process as ASP.NET, and that in this case is w3wp.exe. And the request is actually going to be serviced from a kernel level HTTP listener that is built into Windows Server 2003 and higher, and that will decide which worker process to dispatch it onto. The ISAPI extension is still registered here, and that is important in IS6, so it knows which it still supports the ISAPI interface, which is the only way to extend it sort of at the lowest level. And again, ASP.NET has done that. So this is how requests are dispatched onto ASP.NET. They go through the ISAPI extension, even though it's in the same process now, and the ISAPI extension will then dispatch it onto an ASP.NET handler factory. Okay, and the rest of it stays the same. And then the only difference in IS7 is that we no longer have the need for the ISAPI DLL, because the ASP.NET is again a first-class citizen here. So when a request comes in through the kernel level HTTP listener onto the worker process, it actually will just go directly to the page handler factory, the object that implements the HTTP handler factory interface, and that will dispatch the request onto the endpoint. And again, the same stuff happens over here that happened before, the whole parsing, compiling the first time, but then subsequent times it'll just load it directly from memory. So this IS7 obviates the need for the ISAPI model. If you don't want to use it, you can simply map things directly onto managed classes in ASP.NET. We now turn our attention to the pipeline itself in ASP.NET and what happens after IIS hands off the request to ASP.NET. So there are quite a few classes involved in this picture. The first thing to know about how ASP.NET manages the request dispatching is each application in IIS that hosts ASP.NET content is going to have a dedicated application domain associated with it within the worker process. And app domains are a .NET construct that give you process-like isolation, although not quite as robust and strong as process isolation, but they give you type localization. Assemblies are always loaded relative to an app domain, and the basic idea is within your .NET code in an app domain, anything you do really should not have effects on other app domains that might be loaded into the same process. So this is the mechanism that ASP.NET uses to create isolation between applications that are hosted inside of the same process. Now in IS 6 and 7, you can always actually create a separate process to host your application. So you have that option by setting up an application pool into which only your application is mapped. But do keep in mind that if you do map multiple applications to a single worker process, you still do have an amount of isolation provided by the app domain construct. Okay, so the request comes in. It gets dispatched via a class called the HTTP runtime. That's sort of an internal class you probably won't ever end up touching. But the runtime is going to prepare an instance of a class called HTTP worker request, which happens to implement this HTTP map path interface. And this will have all the details necessary to about the request to continue processing it. So the idea is it creates this lower level object that contains all the information needed to process the worker request, and begins handing it down the pipeline. Now, one of the things that's going to happen in addition to the worker request being constructed is this class called the HttpContext. And this is the first one we're encountering that you will actually end up using quite a bit. The HttpContext class is constructed, you have a brand new instance of this guy constructed for each distinct request that comes into your application. And the context is going to have references to all the relevant pieces of information you might need to know about the request. For example, you have access to the request object, HTTP request, the response, the session state, the application state, among other things. So anytime you're looking for context or request relative information, you typically are going to be reaching for the HTTP context object. Now, let's follow the path of the request at this point. Once those two things have been constructed, the runtime is going to dispatch the request onto the application. But as with the handler endpoints, the application class goes through a factory class as well to instantiate it. So there's an HTTP application factory, and that becomes important later, as we'll see, because you may end up needing to intercept that so that you create different application types. So the applications factory is going to construct an instance of the application class, which by default is HTTP application. So that's the standard class in ASP.NET that represents an application. And there is sort of conceptually one of these guys per application, although in practice you actually end up getting multiple instances. But for the conceptual, the way you want to think about it is this is your global object. Anyway, this guy implements an interface called HttpAsync Handler, which is actually the base interface for HttP Handler. And that has a method called begin process request, which this runtime is going to dispatch the request onto. So it's basically going to go to the application and say, okay, here's the request, let's start processing it. And the application class is going to continue execution on that thread and locate the appropriate handler factory associated with the endpoint request coming in. So it's going to look at the extension like ASPX or ASHX and say, okay, I need to go find the factory that's capable of processing that type of request. And the handler factory, if it's a page, for example, will end up just dispatching onto a page endpoint, as we saw earlier, which implements HttP Handler. But this is a very general mechanism. So it doesn't have to be a page. This can actually just be anything that implements the HttP Handler interface. And we'll talk about how you might build alternative endpoints that implement that interface directly. Now, one other piece of information that's useful to know is hanging off of the application here are a series of modules. So these are modules that can intercept various events that happen in the application, and they all implement the HTTP module interface, and they can do whatever is useful to at sort of intercepting and processing or manipulating the request. So, for example, things that are implemented in modules typically include security. Authentication is a module level feature. Authorization would be a module level feature. Things that you want to have happen outside of the actual processing of the request and have happen across all requests coming into the application. These are things that you might want to implement in terms of a module. Okay, so in the end, there are 3 extensibility points here that you typically will end up using. The most common one that you'll end up using is, in fact, the application class. And we'll start with that next. The application class you write in ASP.NET by creating a global.asx file and building a class that derives from HTTP application. And you can then override events, you can intercept requests, etc. The second point of extensibility are the modules. So you can build your own HTTP modules here and attach them to the application class. The functionality in a module is actually very similar to the functionality that you might build into an application, and we'll talk about the difference between these two. When might you want to prefer one over the other? But that's extensibility point number 2. And then number 3 is right here, the actual HTTP handler class. You can write your own HTTP handlers. Let me redraw that. Your own HTTP handlers, and have them process their own custom extensions to do something interesting. Okay, so build applications, build modules, or build handlers. Those are the options you have for extending the pipeline. The last point of extensibility I want to take a look at is building a custom module. So we've talked about building custom applications, building custom handlers. The last thing you might want to do is build a custom module. And to preface this, let me just make sure everyone's clear. Custom modules are essentially equivalent to custom applications or global ASAX files. So you can do everything in a global ASAX file that you can do in a module, but we'll talk about why you might want to do something in a module versus global ASAX in a few minutes. So just keep that in mind, that in terms of functionality and types of things you might do, modules are essentially equivalent to top-level application objects. So how do these work? So conceptually, modules are similar to ISAPI filters in IIS, if you come from that world. They give you the opportunity to intercept all of these application-level events, and you can deploy them into a site just by dropping them in the config file. And they have the interface is HTTP module that you'll use to build them. And it's a very simple interface. It just gives you one method, basically, the init method. And init gives you a reference to, what else? The application object. So it's going to give you a reference to the application object, and what you'll do is typically wire up event handlers for any event that you want to tap into in the application. And as we'll see, quite a few pieces of ASP.NET are actually built using modules, and we'll take a look at all the various modules that are installed by default in your machine in a few moments. Let's start just go by writing a custom module though. So what I'm going to do is go back to the global ASX file that we wrote earlier, and I'm going to take this functionality, the begin request and end request, and re-implement it as a module instead of an application class, so you can sort of see the difference between the two. So let's begin by adding a new class definition, just like we did for the custom handler. And let's call this the timer module, because it's going to track page timing. And let's put this in a namespace. And let's take out the constructor, which I'm not going to use, and begin by implementing HttP module. And again, we just have that pair of methods. Dispose I'm not going to take advantage of here. And what I'm going to do in init, it's funny, the wizard always names this parameter incorrectly, so I like to change that. Init is, we're going to wire up event handlers. So I'm going to grab the application, and I'm going to wire up the begin and end request events, just using standard delegate subscriptions here. And let's do the same thing for end request. Good. Okay, and then let's bring over our implementation from global ASAX. So inside of begin request, we're going to capture the current time right here. Now in this case, I actually am going to be overlapping with global ASAX, so I do want to make sure the string is distinct. So let's call this the timer module start time, and end request is going to be the same thing pretty much as we had here. All right, in fact, let me change the order so it's a little more intuitive to look at here. So begin request is above end request. Okay, good. So, and let's change this string too to make sure they match. Okay, that should be good. Now you'll notice the context is not working for me here. I can't refer to the context. That's because it's not part of the module class, obviously. I'm just building a class that implements HttP module. So what I need to do is actually get access to the application somehow. And it turns out the application is going to be the object coming in as the sender of this event, because it's the object that issues the event. So what you can do is just say HTTP application app is equal to sender as an HTTP application. And then you can say app.context. And we'll do the same thing down below here, so we can easily reference the application anytime we need to talk to the context or the response. So that's pretty much the only thing we'll have to change in our implementation. Otherwise, it should all work fine. Okay, so there we go. Now I have the timer module in place. Notice my global ASX is still commented out, so that is not going to be contributing to the response at all, so it should be just in the timer. So that's a valid module now. Let's just compile it and make sure we don't have any errors. Okay, compile succeeded. And the last thing I need to do is actually configure it. So you're going to go into your configuration file, locate the HTTP modules section, and we're going to add another module entry here. So add name equals timer module, and then you just specify the type, which in our case is ps.timer module. Okay, and again, if it were an assembly, if it weren't part of this application, this web application under app code, I would have to specify comma the assembly name, and if it were deployed in the GAC, you'd have to do the full version, culture, and public key token, just like we have up above there. Okay, so that should be installed. Let's make sure that the class name was right. Timer module PS. Timer module PS looks good. So that should be applied now. Let's go ahead and try running our default page. And notice we're getting the output at the bottom, which is good, just like we did before with application. But now it's being done through the module instead of the global ASX file. Good. And just to show you that this, you don't have to do anything special to configure modules in IIS. They work the same way. If I go browse the same page in my IIS installation, notice that I'm also getting the output of the module down below. So you don't have to configure anything differently because you're not dealing with endpoints here. You're dealing with classes inside of the pipeline that are simply tapping into various events. The first point of extensibility that we'll be taking a look at here is the application. So in any ASP.NET application, there's always a global application class, and by default, the application class is going to be an instance of HTTP application, as we mentioned. So that's the base class for applications, the HTTP application. You can customize it though. You can actually create a derivative of application. And the reason you might want to do that is it exposes a number of events that you can add handlers for that will be invoked during the lifetime of requests that come into the application that you're building. So unlike a handler, an endpoint, which would be associated with a particular request, the application gives you access to various points in the request processing lifecycle of every single request that comes into your application. So you'll tend to do things at this in the application that are global in your application. So things like doing security checks at the beginning, or initializing some data that's shared across all of your application, all of your pages. It also serves as the initial entry point for a request. So if you want to somehow reject a request, for example, if you want to do some pre-processing before the handler actually gets invoked, you can do that in the application class. You can actually preempt the request and stop it from going back. It also is a collection of global resources here. The cache and the session state are all accessible through the application class as well. And it's accessible through the context and page classes as we saw before. So if you put some functionality into your application class, you can always access it from other locations in your site. Okay, so that's the role of the application. Here's what the base class, or what part of the base class looks like, just to give you a sense for what you're going to be deriving from. So the application class, HTTP application, implements the HttpContext async handler, as I mentioned before. And that has the begin process request method that's going to initiate the request processing and go locate the page handler factory typically. But here's what's more interesting to you is the properties that you can use to access pieces of data about the request in the application. So the application object, that's the state in this case, so it's not self-referential. The context, you can always go find that guy. The various modules that are installed with this application. The request and the response, the server, the session, and the user. We saw a lot of these via the context earlier, and in fact many of these just map onto the properties that are defined by the context, but they're here for convenience. A couple of methods that are interesting to know about. The init method is a virtual method you can override and it's called at the beginning of the application's lifecycle. And complete request, this is one that I was sort of referring to before. This lets you, if you invoke it, it actually stops the request from completing processing. And what you typically would do is set the error code for the response and then call complete request if you wanted to stop the processing of that request. So those are the various things you can access in the application class. And the way you're going to customize, the way you're going to build these is you're just going to create a file called global.asx, and that file needs to be placed at the top level of the virtual directory. And then when the application is accessed, it will be parsed and compiled into an assembly, much like pages are, and a new instance of the application class or your derivative will be constructed. So you're going to create a class that derives from application and have it use that class instead of the default HTTP application class. And we'll do an example of that next. Let's try building a application class here, a custom application class that intercepts a couple of events. So I'm going to start by adding a new global application class to our project. Now, for some reason, they don't support adding code behind for global application classes in the wizard, but you certainly can do it. And I'll show you an example of that in a bit. But for now, let's just stick with the default generated code. Now, you notice that they do put in a number of handlers here for us, application, start, end, error, and session start and end. I'm not actually going to use any of those, and we'll come back and talk about them in a minute. But let's go ahead and start by writing a function that we want to handle. I'm going to tap into the begin request and end request methods of the application class. So I'm going to create a public void application begin request, which takes the standard event arg signature of object source and event or event handler signature, event args e, and we just drop it right there. And I'm going to replicate that function for to do the equivalent for end request. So there's begin request and here's end request. Now, what I'm relying on here to get these wired up to the proper event is auto event wire up, which is on by default. And that will take care of taking this name. As long as you name the function exactly that, application underscore begin request, it will be subscribed to the begin request event of the application. So let's do something here like a timing thing. Let's keep track of how long it takes for each page request to complete its processing. And then we'll just print it out at the bottom of every page, just as an example. So here what I'm going to do is I'm going to capture the current time, which is just a date time dot now dot to, well, let's just capture that. And what I want to do is save this. Now you want to be a little bit careful about where you're putting your state if you are going to do some state manipulation inside the application class. Because if you recall, this is going to be accessed, well, your application is going to be accessed by many different threads concurrently. It turns out they will actually create a distinct instance of your application class for each request. But in general, instead of putting in member variables for this class, I recommend using one of the state bags that are out there. And the one that often becomes useful when you're building application logic is the items collection in the context. So what I would do to store information between application begin request and application end request is just reach into the context.items collection and give it a start time, let's say, and set that equal to the datetime.now. So we're going to cache the current time right there. And then down here, we should be able to pull it out again. So datetime t equals context.items indexed by start time, just like we did earlier. As a date time, we need to coerce it back into a date time type. And actually I need to cast it. It's not a reference type. So we'll just do this. Okay, and then once we have a time, let's calculate how long it took by creating a time span and setting that equal to datetime.now minus the start time. So we'll figure out how long it took. And then let's just write something out to the response, let's say. So response.write this page took, and let's print out delta.to, or let's print out total milliseconds. That'll give us a nice number to look at. MS to process. Okay, so there's my call. And now what should happen is every single time a request comes into this application, these two events are going to be tapped into by my global ASAX file, and it will capture the request time when it first comes in begin request, and then by the time we get to end request, it will retrieve the start time and then calculate the delta, the time that it took in between. Notice that the items collection is unique per request, and I'm relying on that fact because I couldn't use, for example, the application state bag because that is global to the application, and I would have several different requests processing at the same time. They'd step on each other. So this one is useful because it's always relative to the current request, and it will never be stepping on state in someone else's page. Okay, so let's go ahead and add another page just for a little bit of variety here. Let's add a web form, and let's just call it page 2 instead of default 2. And all I'm going to do in here is put a little sleep in so that we can slow down the request so we can see it actually take some time. So thread.current thread.sleep, I'm sorry, thread.sleep, that's all we need. And let's say 2 seconds. Okay, so let's go ahead and try running our default page and see if that application logic kicks in. And it does. So that page took 259 milliseconds to process. Let's try going to page 2, which should take considerably longer since I put the thread to sleep for 2 seconds. And there we go. It took 2022.4512 milliseconds. So as you can see, it's pretty straightforward to add logic to your application that affects all pages in your site. And you can do that just by adding a global ASAX file and associating it, putting it at the root of your application, and adding whatever logic you want to include across the entire application. So in the demo I just did, I used 2 specific events to handle the beginning and end of each request. The first was begin request and the second was end request. And on the slide you can see there's a whole bunch of other events that take place between those two that you might find useful. And what I've done on the slide is listed all the events in sequence as they're issued for each request that is processed in the pipeline. So begin request and end request are probably the most common because they surround the entire request process. But there's some other useful ones. Authenticate request. This is useful because by the time this event is issued, the identity of the user has been established. So if the user is being authenticated with Windows authentication or forms-based authentication, this event will be fired after that authentication has taken place. User authorization is another event that is triggered right after that. So once you've identified what access a particular user has, that'll be ready to go by the time you get to that event. There's a cache event. Again, not used too often, but it's used by caching modules to bypass execution of handlers if they decide they want to draw from the cache instead. That's used specifically by the output cache mechanism in ASP.NET. Acquire request state is used to load session states. You can see when each thing is occurring as you go through this life cycle. Pre-request handler execute. This one is actually quite useful. I found it quite useful lately. What this does when this is called is just before the request is dispatched to the endpoint. So imagine you've got a page class, foo.aspx, and before it actually invokes process request on that page, it will fire this event, which gives you an opportunity to potentially manipulate the endpoint if you want to. You could add handlers to it, etc. In fact, we'll do an example of that in another module. But just keep in mind that's sort of your last event, the last event you can access before your page is going to be dispatched onto. And then there's a follow-up event, the post request handler execute. You can use that to do something after the page has actually processed the request and maybe manipulate the response or something. Release request state, so that's going to release session state back. It's going to flush state out to servers if you have that configured. And then update request cache, again, that's used primarily by the output caching mechanism. There are some other events that are issued not with every request, but under certain conditions. So, for example, disposed is going to be fired just before the application is shut down in most cases. Error is a global event that can be handled, that is going to be fired whenever an unhandled exception propagates to the top level of your application. That's quite useful to know about. And then there's pre-request, send request content, and pre-send request headers. So all these events can be used to intercept various points in the lifecycle. Again, the ones that I tend to use the most often are certainly begin and end. Authenticate, if you're doing anything with security, is often useful to use, and then pre-request handler execute you might find useful as well. So keep those in mind. There are some other events that are available in the application class that are not specifically defined as events per se, but these are functions that are going to be called at certain points in time in the life cycle of the application. And several of these are sort of carryovers from classic ASP. The application start event and end event. So these are called when the application first starts and when it completes, and then similarly session start and session end. And what people have traditionally used these events for is for populating data structures that they want to use either across the entire application or within a particular session state object for a given user. And you can still use them for that purpose. The only way to add handlers for these events is to write a function that is named exactly one of these four names with the right signature and place it in your global ASAX file. Let's turn our attention now to building custom handlers. So we've looked at the application class and how you can intercept application level events anywhere in the pipeline. Handlers are something you might want to build if you are trying to create your own custom endpoint that is not a page and you want to process the request in a lower level fashion without the infrastructure of the page and the server-side control architecture around you. So it's worth pointing out initially that every ASPX file does turn into a page, which in turn implements the iHttp handler endpoint. So by default, all of your pages obviously are endpoints, and the only requirement that's necessary to become an endpoint is to implement this interface, iHttp handler. So what you can do, if you want to, is build additional classes that implement iHttp handler directly. And we'll have to configure ASP.NET to recognize this handler, and we'll also have to map a specific path or extension onto this handler. So we need to tell ASP.NET when to invoke this particular class's process request method, and how to map it onto us. And as we'll see in a few minutes, for handlers to be invoked, the path in IS 6 and earlier must be mapped onto the ISAPI DLL for ASP.NET. So this is, and I'll show you an example of this, but if for example, you want to associate the extension foo with a new endpoint, the foo extension is not recognized by IIS by default. So you're going to have to go into IIS and tell it, look, if you get the foo extension or a request for a foo file, go ahead and hand it over to ASP.NET. And at that point, ASP.NET will figure out how to dispatch it onto your custom handler. But just keep that in mind, and we'll do examples of that in just a moment. So what is this interface, the iHttp handler? Well, here's what it looks like. So iHttp handler, it has one method that's really of interest to us, which is process request. And notice what it takes for a parameter, a context. So there you have everything you need to know about the current request, and you can go about populating the response if you want to, setting the response content type or whatever makes sense. You can implement this is reusable, and the default factory will actually pool you if you return true here. So if you end up returning true from is reusable, it will pool instances of your class and dispatch onto them after the fact. So if you have any state that you maintain across requests in a handler, which is not usually a good idea anyway, you definitely want to return false here. But in general, it probably won't make much difference either way. Now, if you actually want to take control over the handlers at a higher level, you can also implement the factory yourself. And the factory is exposed via the HttpHandler factory interface. And this just gives you a level above that, a way of retrieving the handler. So it says, hey, go give me the class that is capable of processing this request. Here's the URL, here's the request type, and here's the path that was requested, as well as the context. And given all that information, you could then go figure out which instance of what class you wanted to use to process the request. And these are both configured the same way, so it doesn't matter which interface you implement. ASP.NET will invoke either process request or get handler for you to initiate the endpoint dispatching. Let's go ahead and build a custom handler in ASP.NET. I'm going to start by commenting out our end request implementation here, just because I don't want to have this additional data appended to my custom handler implementation. So let's go ahead and close that out. So to build a custom handler, we're just going to create a new class definition, and let me call this csvhandler.cs. And let me describe to you what I'm going to try to build here first, give you sort of a motivation for what we're trying to do. So a custom handler is going to be something that processes a request and does whatever you want, right? You associate it with some endpoint, and you literally have full control. You can set the content type, you can respond with whatever data you want to. You could build a web service this way, a very simple web service, or very complex. What I'd like to do is send back some data. So I'm thinking I'm going to prepare some comma delimited list of values that could be processed by a program like Excel, for example, in CSV format, and I'm going to stream that back as part of a response. So for example, if I put a tag on my page here, an anchor tag, and I set the anchor ref to href to data.csv, and just call this get data. What I want to have happen here is when this tag is clicked on, the anchor is clicked on, I want this request, which is going to be made to my ASP.NET application, to map onto my custom endpoint, my custom handler. And I'm going to build that handler to go retrieve some data and send it back in CSV format. So this is one thing you can do with custom handlers, is you can build custom endpoints that collect or serve back data in some specific format that might be useful to you. And then you can associate it with a specific extension, which is also going to be useful. So let's go ahead and try building that. Let's start here by putting it in a namespace. And I'm going to get rid of the constructor, and I'm going to implement the HTTP handler interface. And there's the two methods we looked at on the slide. And I'm going to return false for the pooling request. And here's where we're going to do our work. So to process the request, by the time we get here, the request will have gone through the pipeline, and we are now at the endpoint. And it's going to be up to us to serve back some content. So this is where I might go out to a database, retrieve some data, and then format it specifically so that the client can receive the results. So let's first set the content or the type of the response. So context.response.content type, and we'll just set the MIME type here just to application /CSV. It's a very common MIME type for this type of thing. And let's go ahead and write something to the response now. So context.response.write. And let's just do some numbers. 1, 2, 3, 4. And let's do a carriage return new line, 5, 6, 7, 8. So a couple of rows of data separated by commas. And again, that's where you could pull some data out from whatever you wanted. One other thing you could use this for is you could look at the endpoint request, the actual URL, and you might want to go read that file and then do some processing on it before you send it back. That's another interesting example of using handlers. So I actually have that's a valid handler right there. That's an endpoint. We need to now wire that up. So when a user requests this endpoint ASP.NET will map it onto this particular class and create an instance of it and invoke our process request method. So to do that, we need to go into the configuration file. And ASP.NET has a section in here called HTTP Handlers, and you'll see a couple things already in here for ASP.NET 3.5. So all we're going to do is add another handler. You can specify the verb you want to use. So let's say we're going to restrict people to only using the GET request in HTTP. You could use star if you didn't care. And for the path, I'm going to be very specific about this and say the path needs to be data.csv. So only that specific path should map onto this endpoint. You could also use star.something as you see done up here. That's a valid thing to do. And let's go ahead and specify the type. So the type is going to be the actual class definition, which in our case was ps.csv handler, as you saw in this file here, ps.csv handler. And we also need to specify the assembly. In this case, because we're in the same project, the same application, the assembly is inferred, so I actually don't need to specify it here. But in general, you would then follow this with a comma assembly name, and you could even add the strongly named elements as well if you had an assembly that was deployed in the GAC. But that should do it. So ASP.NET will now see that I have this particular path wired up to this endpoint, and if a request comes in for that path, it should construct an instance of our handler class and map onto it. So let's try running that. Clicking on the link to data.csv, and notice I got prompted. It said, hey, do you want to open or save the file? Because I returned the CSV content. And if I click on open, notice it drops me into this little Excel-like interface. So this is actually a custom little thing I threw on because I don't have Excel installed, but it shows XLS content. So if I had Excel installed, that would open up Excel and display the data directly in there. So that's an example of a custom handler that we're using to send back specifically formatted data outside of the page architecture. You're just building up your own endpoint and defining exactly what is going back and how it's going back. So next we'll take a look at how do you integrate this into IIS, because things get a little bit different when you start actually deploying it there. We now have our custom CSV handler working within the ASP.NET development server. And as you saw, I was just running this inside of Visual Studio and launching it. And the only association we had to make to get that to work was to register the CSV handler inside of the HTTP handler section of web.config. Now, what I wanted to show you next is how you would actually deploy this to IIS. And again, this is going to differ depending on which version of IIS you're deploying to. We're going to start right now by showing you how to deploy to IIS 6, or the equivalent of it. And later we will discuss deploying to IIS 7, because that again is a little bit different. So let's go ahead and put a virtual directory. Let's put an IIS application on top of the pipeline demos directory, which is where this is currently living. So I'm going to add a new application, call it pipeline demos, and I'm going to change the app pool just so that I can show you what it looks like to deploy to IIS 6 instead of IIS 7. So what I'm doing is running IIS 7 in classic pipeline mode, which means that it goes through the ISAPI filters before it dispatches onto ASP.NET. So it behaves much closer to the way that IIS 6 behaves. And for the physical path, I'm going to drop it onto our pipeline demos directory, which is where my application is. Okay, so let's go ahead and start there. Now, what I thought I would show you to begin with is how it will not work just deploying as I just did. So if I go ahead and browse my default.aspx page here from within IIS and click on this link for data.csv, notice we get a 404. And we're getting that because CSV is not a recognized extension by IIS, so it's not going to dispatch it onto our handler. So what you have to do in IIS 6 or IIS 7 if you're running in the compatibility mode for the pipeline is go add another handler mapping down here. And what you want to do is add a handler mapping that's very much like the ASP.NET handler mappings. So in this example, actually let me close this out and restart it again so we get the right mapping interface here. So I'm going to bring that site up, bring the application, HTTP pipeline demos, go to the handler mappings, and notice ASPX now is mapped onto ASP.NET ISAPI DLL. So that's the same mapping that I need to create. I need to create a mapping between .csv, or in fact data.csv if I want to be that specific, and this ISAPI DLL so that it gets mapped over to ASP.NET. So let's go ahead and add a script map, and the request path, let's go ahead and make it specific to data.csv, and the executable is going to be the same executable as ASPX files have, and let's just call this a custom CSV handler, and that will add a script map entry for CSV. And because we're mapping it onto the ISAPI extension for ASP.NET, it will get over to ASP.NET, and that will allow ASP.NET to kick in our custom data.csv handler here. So let's go ahead and try running the page again inside of IIS. And this time when we click on data.csv, notice I get prompted with the CSV download again, so it got mapped onto ASP.NET, and we get our same little Excel-style interface for the data. So keep that in mind if you're deploying to IIS 6 or IIS 7 in compatibility mode for the pipeline. You're going to have to map any custom extension onto ASP.NET's ISAPI DLL before any of your custom handlers are going to be properly invoked. Before we leave the topic of custom handlers, I want to also mention this possibility for building a custom handler, which is the .ashx extension. It turns out ASP.NET has a pre-built extension called .ashx, which lets you place a custom handler implementation directly into the file or as a code behind file, and it will compile that class and dispatch a request onto it. And the advantage of using ASHX is that you won't have to configure anything. You don't have to configure anything in web.config, and you don't have to configure anything in IIS to get a handler, get a request dispatched onto your own custom handler class. So let's go ahead and just try this real quick to give you a sense for what's possible. So back here, recall what we had to do to deploy our custom handler. We had to register an HTTP handler entry for the custom handler. We had to write the class, and we also had to wire it up in IIS to tell it to pass requests for data.csv onto ASP.NET. So let's write another custom handler, but this time I'm going to use the generic handler template, and let's just call it sample.ashx. And notice they actually stub out the implementation for you. So you just place your class definition directly in the ASHX file, and you can set your content type, and you can write responses back, and that all sort of works as you would expect. So let's go ahead and just try putting a reference to this custom handler up on our main page here. And just say call simple handler. And this is going to map onto sample.ashx. So again, the advantage here is it's not deriving from page, so you're not incurring any of the page architecture around you, the server-side controls and all that. So it's really for building raw endpoints in your system, but using ASHX avoids having to create associations between extensions. Now, keep in mind, you often are building a custom handler because you want to create custom associations with extensions. And if that's the case, you definitely don't want an ASHX. That's not going to help you. But if you're just using it to build a custom endpoint, you don't care what the extension looks like, and all you want to do is write some code to process the request, this is a quick way of doing that. So let's go ahead and try running it. And all it should do is say hello world, and it does. So very straightforward. So keep that in mind as you're building custom handlers. That might be useful if you're just looking for a quick way to get a custom handler up and running without having to go through the configuration. Now, before we jump into building applications, modules, and handlers, let's first take a look at the HttpContext class, because this is something you'll end up using in most of those extensibility point implementations. So the context class, as I mentioned, is created uniquely with respect to each request that comes in. So you'll have a distinct instance of this class for each request that comes in. And keep in mind, ASP.NET could be processing many requests concurrently. It's a multi-threaded environment, and it's pulling threads from the thread pool and dispatching requests onto endpoints. And these are all happening concurrently so that we don't have to serialize requests from multiple clients. So what we're going to have is many different instances of this HttpContext class, one for each request, and it's going to be affiliated with a particular thread, in fact, a request thread. And what's interesting about this class is it stores all the request-specific data that you might need to know. That's where you have reference to the request and response objects. In fact, as you've probably seen, the page class that we've been working with has access to request and response, but it turns out that those are really just pass-throughs onto the context object. So the context object is the ultimate holder of these request relative resources. So that's where we'll go reaching for them. It also stores links to all the relevant classes for you. So the application, the session, pretty much anything you'd want to do or inspect with respect to the request is going to be there. And it's passed as a parameter to a bunch of methods, the most notable of which is the process request method of the HttpContext handler interface. Since that's the request to actually process a request, that's the method to process a request, you're going to need the context to do it. Now, what exactly is inside of this context object? Well, if you just go poking around, here's a short list of what you'll find. The first thing of interest is there's a static property called current. And this is interesting because what it actually does is let you retrieve the current HttpContext object relative to the thread that you're on. It turns out the context object is stored in the equivalent of thread local storage in .NET. So that you can always reach up into your current thread and find the context object. And the way you do that is by accessing the static current property. And I'll show you an example of that in just a second. The other thing you can access is the application object. And this is actually the application state bag, something you probably won't use too much in ASP.NET, as we'll see later. But it is there, and it's accessible using the application property. If you want to actually grab the HTTP application object, the instance of the global ASAX guy, there's a property called application instance, which gives you access to that. There's the session object, which we're all familiar with, I'm sure. The request to the response objects, that's where you might manipulate cookies or look at the query string, among other things, or just write to the response. The user, this is a good one to know about. The context has access to the user, which is a reference to the iPrincipal interface defining who is currently accessing who has made this request if they've been authenticated. If they haven't been authenticated, that will just mark it as anonymous. It's got a reference to the handler. So once the endpoint has actually been established and constructed, you'll be able to access it through the context object. This is the endpoint. The items collection, this is interesting. We'll take a look at later as well. This is just a state bag, name value pairs, that you can put things into and then pull them out later during the request processing. So you might find that useful as you're building modules, for example, as we'll see in a few minutes. Server gives you access to the server utility class, and the error object is an exception that might have occurred. Okay, so let me just show you a short example of using the current object in HTTP context. So I'm going to go back to our sample environment here. And let's go ahead and create a brand new application. And what I thought I'd show you is just an example of creating a class definition that uses the HTTP context, how it's possible to use the context from pretty much anywhere. So let's just call this Pipeline demos. And I'm going to go ahead and add a class definition here. And we'll invoke a method on this class from within our page is the goal. So one of the interesting things about the context class is that you can access it anywhere as long as you're on the request thread. So let's just call this helper. And we'll say, yes, please go ahead and add that to the app code folder. And let's put this in a namespace, as we always should. And public class helper is fine. In fact, I'm going to make this a static class because it's only going to have static methods. And I'm going to bring in a reference to, I've already got it, system.web, good. And let's just write a public static function void write to response. So we're just going to write something to the response, and inside of here I can just say HttpContext.current. So there's the static current property, and then I can grab it and just say response. Notice I have access to all these things that we looked at on the slide there. Dot write. So I'm going to do something kind of silly here and just write out a hi from the helper class. But you can probably imagine other things you might do here. You might, go look at the query strings. You might look at cookies. You might do anything else that would be useful in the context of building a class. And the interesting thing about it is we don't have to pass a parameter into this function. We can just assume that the class is going to be used in the context of a web request. And if that's the case, you can always access the context via this static current property. So let's go ahead and try using this class. Let's just go call it from within our page, which we know is going to be executing on a request thread. So I should be able to say ps.helper.write to response. And let's go ahead and try running that. And that should be all we see in the helper in the result, because I didn't have any content in my page. Okay, so you can use the current object, and again, the context class is your key to anything related to the request. You can go access the request, the response, the session, etc., and do whatever makes sense for you. One way to get a sense for what's possible in a module is to look at how ASP.NET uses modules as part of its implementation. And you'll see a lot of these things tend to be application level functionality. For example, the output cache module is responsible for the caching of pages and sending responses back from the cache directly. So that happens before the endpoints are actually dispatched onto. The session state module, those are things like retrieving session state from a dedicated server. Those are all that will have to happen inside of the or outside of the request endpoint. Authentication, security is a very common thing to implement as a module because you want to have it apply across all of the pages or endpoints in your site, and this lets you do so by plugging in a module at the top level and tapping into the various events in the pipeline. So primarily security, but there's some other ones as well. Let me actually open up the configuration file, the machine level configuration file on for ASP.NET, and show you some of the modules. So it's a useful thing to go poking around in. So go to Windows, Microsoft.NET, Framework, version 2. That's where the config file is stored, even though you have 3.5 installed. This is where the core config is. And let's go ahead and do a search for HTTP modules. And there's all the handlers above us. You can see a lot of those. So here's the module collection. And again, just note some of the things that are implemented here. So there's the output cache module, there's the session module, there are all the various authentication modules, authorization modules, profile data store is handled as a module, error handler module, among other things. So useful to see what ASP.NET has used modules for as you try to fit them into your own applications and decide what makes sense for you to build up and deploy as a module. The final thing I'd like to mention about modules is how do they fit into the features that we talked about with respect to global ASAX, because they're very much redundant. Everything you can do in a module you can absolutely do inside of global ASAX. So it's not always obvious which one you should be using, and in many cases it doesn't really matter. And if it doesn't really matter, you probably just want to stick with global ASAX because that's the simplest way to intercept these events and add application level functionality. And then you can very easily take that functionality and encapsulate it in a module at some later point in time, as I did in the demo earlier, if you decide you want to go in that direction. So what's the advantage of building something as a module as opposed to putting that functionality directly in global ASAX? The primary one is you can build a module as a separate class library, which means you can deploy it independently of the rest of the application. So imagine you built a security module that you want to apply to several different web applications on your machine. you could deploy that in the global assembly cache. So you can deploy modules in the global assembly cache if you build them as class libraries. And then you could install that on the machine as well. You can actually go to the root machine web.config file and go in and add the module to the configuration file, reference the deployed module in the GAC, and suddenly it is deployed, or it is in effect across every single ASP.NET application on that machine. So that's one powerful thing you can do with a module that you can't do in a global ASAX file. Is you can deploy them in a much wider scope, and you can also make it much easier to sort of hand over to someone and say, here, drop this into your web application. It's just sort of a pluggable piece of functionality you want to deploy. Now, there are a couple things you can do in global ASAX that you can't do in modules as well. For example, those 4 events that I talked about briefly, the session start end and application start end events, those are only accessible via global ASAX. You can't tap into those in a module. And there's also a feature called declarative object instantiation, which actually lets you place instances of classes inside of global ASAX and have them referenced by pages. I almost hesitated to describe that here because it's not something you'll tend to use very often, and I wouldn't encourage it, but if you're looking for the differences, that is one of the differences between the two approaches. So we've seen how to deploy custom handlers to an IS6 installation, or the equivalent of it. I used the backwards compatible pipeline for that. What I want to do now is show you how to do it directly in IS7. So if you're going to use the integrated pipeline in IS7, there's no need anymore to create an association between your custom extension and the ASP.NET ISAPI DLL. That was really only there for IS6 and earlier. Now that IS7 understands ASP.NET classes natively, all you have to do is register your custom HTTP handler with an extension in IS7, and you're done. You don't have to go through this multiple step process to actually do the deployment. Now, the place you're going to do this is inside a different section of the config file. It's called system.webserver, and this is reserved for IS7 configuration. And it also contains lists of modules and handlers, and these are the exact same modules and handlers we were looking at before. They're .NET classes that implement iHTTP module and iHTTP handler. They also use this same section to install native modules as well and native handlers. So it works with both, and IS lets you throw in whatever you want to, and they all get treated as the same collection. So you could type this in by hand, but it's much more likely you'll just end up using the Internet Information Services Manager to configure it. So let's go ahead and try doing that. I'm going to go back to IIS, and let me just delete the existing application and add it back in again so we can get it all configured properly. And I can show you from the beginning. So we're going to add an application, call it Pipeline Demos like we did before. And this time I'm not going to change the default application pool. I'm going to leave it at the default pool, which means it's going to be using the integrated pipeline. And I'm going to set the path equal to cwac demos, wac pipeline demos. And what we now need to do is go in and configure the handler mappings. So just like you would have configured a script map entry in IS6 or earlier, we configure a handler mapping in IS7. And we're going to add a managed handler mapping so that we can map CSV requests onto our custom class. So the request class is going to be data.csv, just like it was before, and the type is going to be ps.csv handler, which is the type of our custom class. And let's just call this custom CSV handler. And that should create the association between the two. And just to verify it's working, let's try running it now. And go ahead and click on Get Data, and notice we get prompted to bring up the Excel data. So that works fine. And we didn't have to create the intermediate association with ASP.NET ISAPI. Now, to see what that looks like, you can go back to your project and open the configuration file. And one thing to note about IS7 is if you're not running in the non-integrated pipeline, it will ignore the handlers and modules section that is under your system.web element. So you'll notice in ASP.NET more recent projects that they actually inject a web server section down below with the same collection of handlers and modules that were defined up above for the previous versions of IIS. And here's the line that was added for the custom CSV handler that we just used the interface to put in there. So you can very easily see exactly what it adds for you and where that goes in your configuration file. So that's all that's needed to set up a custom HTTP handler inside of IIS 7 when you're using the integrated pipeline mode. There's no need to go set up any additional configuration. Hi, this is Fritz Onion with Pluralsight, and I'll be talking about the pipeline here. So we're going to dive in a little deeper into ASP.NET, looking under the covers at how requests are actually processed and dispatched onto endpoints. And this is collectively, the entire set of classes and the entire process is collectively known as the HTTP pipeline. So that's what we're going to be focusing on in this module. And I'm going to start by looking at how ASP.NET works. We're going to sort of go look at an ASP.NET request and talk about what happens from the time that it actually reaches port 80 on your machine until the time that it ends up processing the request as an instance of a class. How does everything fit in between there? How do we actually get from the initial HTTP request to the machine all the way to a request onto a method in a class definition? So we'll kind of trace through that whole sequence and look at how each piece participates. And as we do that, we're going to point out points along the line that you can inject your own code, places that you can customize to create alternative routes or different behaviors along the way. So that's our primary goal here. We're going to look at how things work, but more importantly, we're going to look at how we can extend the pipeline. And that's where this becomes interesting, because you can do more than just standard page requests and standard web service requests. You can actually build your own raw endpoints. You can build custom handlers that intercept requests, and you can also build application classes. And those are the 3 points of extensibility that we'll be taking a look at. One more thing I will point out towards the end is the distinction between IIS 7 and its predecessors, specifically IIS 6 and 5, because things get a bit different here. In IIS 7, the handlers and modules that we'll be talking about can actually be used at the top level as first-class citizens inside of the web server, whereas in IIS 6 and earlier, you always had to go through a layer before you got to those handlers and modules. So we'll take a look at how that might change your development style or the possibilities with extending the pipeline.